Okay, inverse secant. Again, secant on its full domain is not one-to-one, so mathematicians have decided to, when we want to talk about inverse secant, to restrict it to 0 to pi over 2, pi over 2 to infinity. Notice asymptote at pi over 2, because at pi over 2, secant's undefined. Now, there isn't universal agreement about what interval that secant should be restricted to, but this is what this textbook goes with, and I wouldn't worry about it at all. We're not going to do that much with inverse secant, just a little bit. And then when I reflect the graph across the line y equals x, there would be your graph of inverse secant. Probably one of the most important things we want to remember is that that notation means inverse secant. It does not mean 1 over secant. Making that mistake is a major mistake, and you just lose gobs and gobs of points. So we want to do a similar thing that we did before, just find some basic values. So secant inverse of square root of 2. So that is saying that that's equal to the angle on 0 to pi over 2, and then pi over 2 to pi, whose secant is square root of 2. Now, as far as remembering these things, this guy, this first interval, those are your positive values. And the second interval are your negatives. Because if we think in terms of sine in a minute, because secant is 1 over, or not sine, cosine. If we think about secant and cosine, secant is 1 over cosine. On this first quadrant, cosine is positive. On the second quadrant, cosine is negative. So when you want your positive, when you have a positive value in there, your answer is going to come from the first interval. If there's a negative value in there, your answer is going to come from the second interval. Now, I think of it in terms of sine and cosine, or sine and cosine, in this case, just cosine. That secant inverse of square root of 2 will mean that secant of some angle will be square root of 2. That's what that means. Well, that would be 1 over cosine of some angle equals square root of 2 over 1. And if we cross multiply that, I would get if we cross multiply, I'm going to get 2 square root of cosine theta equals 1, or cosine of theta equals 1 over square root of 2. Then if I rationalize that, and you wouldn't have to do this, but I'm just trying to show you where numbers are coming from here. Rationalizing, we get that. Cosine of theta equals square root of 2 over 2. And now it should look very familiar. Where does cosine equal square root of 2 over 2? And that would be pi over 4. So we now know that secant inverse of square root of 2 is pi over 4. Then doing a similar thing here. And this will be the angle on 0 to pi over 2 to pi over 2 to pi, whose secant is negative 2 over square root of 3. But like I said already, positive and negative, it has to be in that one. That's where the negatives are going to come from. So really doing the same thing, secant inverse of 2 secant inverse of negative 2 over the square root of 3 is going to mean that secant of some sort of angle is negative 2 over the square root of 3, which will mean that 1 over cosine of some angle is negative 2 over square root of 3. Cross multiply, and so I'm going to get negative 2 cosine of theta equals square root of 3, or that gives me cosine of theta equals negative square root of 3 over 2. And I come up with something that should look very familiar, that we should have those values memorized. So then you're asking yourself, What angle has a cosine of negative square root of 3 over 2? Well, what angle has a cosine of negative square root of 3 over 2? Would be 5 pi over 6. And so we just found out that secant inverse of negative 2 over square root of 3 is 5 pi over 6. Now we also have inverse trig of cosine inverse, cosecant inverse, and cotangent inverse, but we are not going to use them nearly as much as the ones we've done before. So there's our basic review of inverse trig. So let's start getting some calculus with it. And so the first thing we're going to do calculus-wise is get the derivative of sine inverse. We're going to come up with it in the end, you just have to remember it. But if y equals sine inverse of x, then x equals sine of y, because that's what inverse things do. They turn stuff around. That's what inverse functions do. And so what we will use is we will use implicit differentiation on x equals sine y. So x equals sine y. Implicitly differentiate the derivative of 1, or derivative of x is 1. Derivative of sine is cosine, but implicit differentiation, derivative of sine y is cosine y, but I just differentiated y. So I follow it by dy dx, which gives me dy dx equals 1 over cosine y. Now that's true, but that isn't the formula certainly not the formula we want. We want the answer to be in terms of x, not in terms of y. So we'll go over here and we'll do a little bit more trigonometry. Y equals sine inverse. That's not what I want to write there. So x equals sine y, or that sine y equals x, which equals x over 1, and sine is opposite over hypotenuse. So there's an angle y. Opposite over hypotenuse. Then a little Pythagorean theorem work will give me 1 minus x squared, and that's from the Pythagorean theorem. So just doing a little Pythagorean theorem work there tells me that that side down there has to be the square root of 1 minus x squared. Then look what I have in my answer. I have a cosine y. Well, cosine is adjacent over hypotenuse. And so cosine y is the square root of 1 minus x squared over 1, or the square root of 1 minus x squared. And so I can carry that back over here. And so the derivative of sine inverse, which turned out to be 1 over cosine y, but I now know what cosine y is, this becomes 1 over the square root of 1 minus x squared. That all we did there is we took this value and plugged it in there, and there's my derivative of sine inverse. Now, you don't need to remember how I got it, but we go through these things of how we get things to show how it all is connected, how inverse functions turn around, right triangle trigonometry, implicit differentiation, it's all connected. Now, that's just if it's just a simple plain variable x, but if we make it a little more expanded a little bit, that the derivative of sine inverse of u, and again, when you see these u's, u represents a function. And so then when we do the chain rule, The sine inverse part gives us the 1 over the square root of 1 minus u squared, then the chain rule, du dx, and then for mathematical preciseness, for the absolute value of u less than 1, because we got to make sure we don't end up with imaginary numbers. Similarly, cos inverse has the exact same derivative but negative. And so you need to memorize this. You don't have to be able to calculate it. We calculated it there, but you just need to memorize it and be able to use it. So let's use it. So sine inverse of e to the 7t. So we are going to use that the derivative of sine inverse of u is 1 over the square root of 1 minus u squared du dx, with in this case u equal e to the 7t. So y prime, so I just start with that formula. 1 over the square root of 1 minus u squared, but u in this case is 7t, then du dx, or in this case dt, the derivative of e to the 7t. And let's make this look pretty, so that's going to be 1 over the square root of 1 minus e to the 14t. Exponents to exponents, we multiply. And that says 147, that doesn't say t. Then the e repeats, derivative of the exponent, repeats, derivative exponent, for a pretty answer of 7e to the 7t over the square root of 1 minus e to the 14t. And there's my derivative. And we'll end this video and pick up with the next problem.